Welcome everybody. We are now going to explore BEStEx, Base and Answers Theory Expander, by quickly introducing its main purposes and the theoretical principles it is based on. We are from Università Politecnica delle Marche in Italy, and this is our team. We made BEStEx plugin with the main goal of enhancing acoustic perception, so we started working up this idea by looking for techniques that could provide the results we were aiming to. Here is shown the structure of our plugin. There are three main blocks defined in three different frequency ranges: virtual base and answer, stereo and answer, and the correlator. Let's start with virtual base and answer. Its main feature is to add harmonics to the signal, exploiting the psychoacoustic phenomenon of missing fundamental. Such phenomenon consists in perceiving a fundamental frequency, exploiting its higher harmonics without the fundamental being present in the signal. This is the virtual base and answer block schematic, whose core is the harmonic generator, named NLD, nonlinear distortion. Its processing is shown here, with this Z main block schematic. We will now talk about the stereo and answer, which operates on the medium range of the audio band. At higher frequencies, the loudspeaker starts becoming more directive. So by using the spatializer, we can make its reproduction more uniform all over the audio band. To achieve this behavior, we equalized the medium range, swapped left and right channels, and we added left to right and subtracted right from the left. Operating on the medium-high range of the audio band, the correlator widens apparent source width by decorrelating left and right channels. This effect is achieved by cascading second-order sections of infinite impulse response all-pass filters. The single all-pass filter transfer function is shown here, and these are its magnitude and phase responses. As you can see, the magnitude response is typical of an all-pass filter, so it remains unchanged, while the phase response has a characteristic slope. Every filter iteration has a random frequency and a random slope. Our approach with the plugin implementation started by looking on the MATLAB resources as tutorials and examples. Laid out the mainframe of the plugin, we tested it with a wide variety of audio samples. After the first testing session in MATLAB environment, we tested it in different DAWs such as Ableton and FL Studio. We presented the processed audio to different people and listened to their feedback in order to evaluate how our plugin sounded. Now let's see BEStEx in action. The plugin has a main switch to turn it on and off, and this is set on as default. Let's put some music. With these two sliders, it's possible to change the distortion shape applied to the signal. It's also possible to filter out the processed signal, change its gain, and tune the wet-dry mix. Then we have the spatializer. Let's activate it. Its sliders change the processed signal gain on left and right channels separately. Last but not least, let's activate the correlator. It is possible to tune its working frequency range. It is also possible to change the number of all-pass filters and their parameters, such as the average delay of the filters and the randomness level, or chaos, for each filter delay. Every time the correlator slider is tuned, the plugin will create a new set of random parameters for the all-pass filters. Thanks for your attention.